Well, thank you. I gave this presentation at the Northeast annual meeting last year, so for those of you who were at that meeting, this is basically the same, but it's, I appreciate being asked to do it again, and it gives me an opportunity to tell more of a national audience about this project. This is actually a report on NCHRP Project 12100, which the problem statement came out of SCOM probably, I'm guessing, 5 or 6 years ago, something like that. The RFP, I think, was issued in early spring of 2014, and we were fortunate enough to win the project, and it started in the fall of 14. So the title is Guidelines for Maintaining Small Movement Bridge Expansion Joints. My collaborators were Pete Wykamp. I don't know that I've seen Pete here yet, but Pete used to be the state bridge engineer for maintenance in New York. He's now with GPI. And then also my colleague and good friend Dennis Mertz, who we lost about a year and a half ago. So let me go ahead and get started. So the objectives of the project stated in the RFP were to develop proposed guidelines and commentary for evaluating and maintaining small movement bridge joints to support the decisions of bridge owners. We were to cover a certain number of minimum things like failure mechanisms, develop performance metrics, and then procedures for maintenance, repair, and replacements of joints. And in the end, the result was to be a form suitable for publication by AASHTO. So that was really what the project called for. And it was broken down into 2 phases. First phase was really information gathering and to develop the original procedures and then an outline for the guidelines. And then with approval from the review panel, we would move into phase 2, which was to actually develop those guidelines. The key parts of phase 1, this was an 18-month project. We had some delays along the way, so actually in the end it was about 2 years total. But the key elements, and then I'm going to talk about, were the first task was to do a literature review, the second was to do a stakeholder survey, and then I'll tell you about the guidelines that were ultimately developed. So first of all, literature review. Of course, going into any project like this, you want to find out what the state of the art and state of practice are with something like this. So we conducted a pretty extensive search, and we also queried the states for information. But frankly, there really is not a lot of information out there about small movement bridge joints. And I'll show you just a few of the more key sources that are out there. And the timeline. As I said, there really wasn't a lot of information out there about the performance of small movement joints. There were 2 prior NCHRP projects. The first one was in '89. That was a synthesis looking at bridge deck joints. That covered the full gamut of types of joints in that one. And there is some discussion of small movement joints, but it didn't go into any great detail. Then in '03, there was a follow-up to that one, which provided a little bit more information, but still not a tremendous amount. It's interesting, there is a study out there from the late '80s, which was done in Pennsylvania, and actually that project did a little bit of what we were trying to do. And in fact, these investigators, they went out and they surveyed over 200 bridges in Pennsylvania. They developed performance metrics and used quantitative ratings of the performance of the joints, and in the end had hard numbers to back up their recommendations for what types of joints they thought Pennsylvania should be using. We followed up with Pennsylvania on that information to see what had ever been done and had this system been put into place, and nobody I talked to in 2015 knew anything about that work. But that is a little bit like what we were trying to do. We also did query the states. We, looked for or gathered maintenance manuals, we gathered design manuals, and we were also trying to gather best practices from all of the states. And so we would collect, good details, any information we had
or could get from the states, we tried to gather that up. So that's kind of how we started. We were then required to do a stakeholder survey, and that was done in the early phase of the project. We surveyed all the stakeholders, including owners, consultants, contractors, and suppliers. And really, we were just searching to find out what your experiences were with different types of joints, what types you used, how well they were performing, which ones you didn't use, the problems that you were having, all those kinds of things. We got over 100 responses, most of them from state owners. I would imagine some of you in the audience took that survey. That would have been back in like early 2015, perhaps, and I appreciate you doing that if you did. This is an example which I can see now is not so easy to see in that washed out slide there, but we, first of all, asked what types of joints do you use for new construction and how well were they performing. And at that time, we were kind of grouping the joints into 8 different types. The colorful slide here on the top is showing what joints the owners were using, and then the bottom one corresponds to how well satisfied they were with the performance of that joint. The second from the right, strip seals turned out to be the most popular and predominant for new construction, and most owners being pretty well satisfied with how they were doing. These results are available in a final report, which is free and online from the TRB website, so you can get these if you want and look at them in detail. We then also asked about life cycle for all the different types of joints. So here's just a plot that's showing the life cycle average lifespan for the joints that are being used. And then we went on and asked the same questions for replacement. What types of joints you were using and how satisfied were you with those joints? Same kind of thing. And then what was the lifespan you were getting out of those joints? And again, there's a lot more results from the survey in the final report, so if you want to see those details, you can dig into those. We also needed to understand the failure mechanisms and how the different joints were failing, and so we asked the respondents to describe for us how your joints were failing. And of all the different responses that we got, we collected up and categorized all the common terms that we would see to describe failures. And so that's what you see here. Again, it's difficult to read there, but you can see that in the final report. The project required us to look at performance metrics. And so we came up with a straw man list of, I think, 14 different performance metrics. They were categorized according to the AASHTO design philosophy. And we basically, for each one of them, we asked the respondents, how effective do you think this criteria would be in evaluating a joint, and how easy would it be to gather the information to quantify the measure? So for each one, there were 2 different metrics. So that kind of bullseye graph there is showing you the average responses for the different constituent groups. Ideally, what we would have seen was some nice collection of metrics down in the lower right-hand corner, which would say these metrics are possibly could be very effective, and the data to use them would be very easy to collect. And unfortunately, we didn't get that. It's a real shotgun view that you have there. But there were a few of them that kind of rose to the top and looked like they would be good. For example, life cycle cost. That was viewed by owners, suppliers, and consultants to be a good performance metrics to look at. Unfortunately, it's also one of the most difficult to gather the information and data for. So while we looked at that initially, in the end, we haven't really proposed a real quantitative measure of life cycle cost to be one of the performance metrics. So those that was the result of the survey, and again, more details are in the final report. So let me just go on and just tell you what you will see in the draft guidelines that were finally produced. The deliverable for the project, there is one part which is the final report, which has all the literature search and the survey results in, and then a separate document which is the one which was drafted and developed to be presented to AASHTO in a suitable form as they described it. So when you look at the document, this is what the table of contents looks like. Starts with an introduction, and then we go into the different types of small movement expansion joints. Talk about modes of failure. Then a section in evaluating joints. How do you evaluate the current condition of the joint? There's a section next on calculating joint movement and sizing the seal, selecting a replacement joint, preparing the header. Of course, the header's common to most joints, so there's a header section. And then the last 5 is a chapter devoted to one class of small movement joint. And I'm not going to go through each one of those, but I will run through sections 1 through 8 so you can kind of see what you'll find in the guidelines. So this was limited to small movements. We defined, or the RFP defined small movement joints as 4 inches or less. So that's what we were restricting ourselves to. There was some discussion with the review panel through the project about eliminating joints. And after thought and discussion with the panel, we have some mention of elimination of joints, which of course many owners are going to, but to get into the details of that was going to be well beyond the scope of this work. We there define what we mean by maintenance, repair, and replacement. And that basically does it for Chapter 1. So types of joints. We eventually grouped or classified the small movement joints into one of 5 categories. The asphalt plug joint, compression type seals, then strip seals, pourable, and then open sliding plate butt type joints. In this section you just have a narrative description. We also have a typical schematic, and then usually 1 or 2 photographs of what the joint looks like when it's new. Next, going into modes of failure, this is where we're taking the information that we gathered from the survey, and for each of those classes of joints, we have a description of typical modes of failure, and then we have a few photographs. And that's pretty much what makes up that chapter. So we had to come up with a way to evaluate the joints and do it or propose in some way to do this systematically, hopefully somehow or another quantitatively. And we proposed to piggyback off of the AASHTO Manual for bridge element inspection and the condition states and the defects that are already defined in that manual. So this is what we proposed. Basically, what you would need to do is to go to your joint, look at the condition state of the joint, measure the lineal feet in each different condition state, and then we proposed a table like this where you go into the table with the highest condition state, the worst condition state, and the percentage of the lineal feet of the joint in that state. And then you move across the table, and that tells you whether you're in a maintain, repair, or replace scenario for that joint. We presented just one table. I could foresee perhaps owners, assuming if they adopt this, you could put in more, instead of just 25% intervals, you could use 20% intervals. You could have a table like this for each different type of joint if you wanted to. But in this way, it's some systematic way to come to an evaluation decision on where you stand with that joint. So the next chapter gets into calculating joint movement and sizing the seal. Of course, the basic calculation for joint movement is in AASHTO specs, but you can go beyond that, and it certainly was true when we gathered information from the different owners. You know, there were some states that really don't do much beyond what AASHTO says in terms of, you know, providing guidance and how you do the calculation, to other states that have tables of movements being calculated, et cetera, et cetera. So we tried to pull together the best practices from all of that. So just the basic equations for movement, and then if you have skew. Then of course the movements are typically being calculated for a nominal temperature, say, you know, 68 or 70 degrees, but then when the joint's being reconstructed, you know, the temperature is different, and so, you know, what adjustment do you need to make for that, you know, on site. And so tables here for adjusting the width for the temperature for steel and concrete. And then just the steps, you want to calculate the maximum and minimum gap based on the current width and temperature that you're taking the measurement at, calculate the shear movement, and then you want to calculate what your max compression is going to be, max tension, shear, etc. And you would have to iterate through to finally arrive at sizing the seal using manufacturer's tables or however the means is to do that. Now then, replacing joints, this is where the performance metrics came in ultimately, and we came up with, I guess it's, you know, 10 different metrics to look at. Obviously, joint opening, joint movement, skew, you know, attended service life, etc. And how did we ultimately, you know, present this? It's in a table like this. And so you see the 5 different classes of joints in the first column on the left there, and then across the top are these 10 different metrics. We chose, except for cases where we have, you know, specific, you know, quantitative values, we decided to use just a high, medium, low categorization of each of these. And so you can, through this, you can look at, you know, what your situation is, and what's going to work best for your replacement. We were also asked by the panel, or the panel wanted to have kind of a guidance. If I have a certain kind of joint currently and I'm going to replace it, what if I want to replace it with a different type of joint? What's involved with that? You know, there are certain switches that can be made that could be perhaps relatively easy. And there could be others that you really just don't want to try because there's just too much work involved. And so this is a table where in the left-hand side you come in with the current type of joint you have, and then across the top you see just a relatively short description of what's involved if you want to switch to that type of joint. And so you can just kind of see, again, what's going to be involved if you were to make that change. Then, Chapter 7 covers preparing the header. This is, you know, common to a lot of types of joints, and so within here you'd see design considerations, determining the size and the gap opening, the replacement procedure. And then from here on out, you're going to see what I think is really one of the nice aspects of the final product, the final document, is you see a lot of pictures which are showing the work that's actually being done. And so here are just a couple examples that show the different steps in preparing the header. So then you have a chapter for each one of the 5 different general classes of joints, and within each one of those chapters you'll see a section that says replacement. So I'm just showing you the asphalt plug joint chapter, but replacement of the joint, which obviously requires the most work and is most descriptive, so we start with that. Next you go to repair, then you go to maintenance, and then the last one are the pictures for the installation. So for example, for the asphalt plug joint, with the replacement you'll see a section just says any special design considerations you have to worry about, determining the joint movement, and then the replacement procedure, which of course is going to be unique to each type of joint. For the plug joint, you see these different 9 steps, and within those 9 steps you'll see some narrative description about how you go about doing that. That's where most of the, that takes up a good chunk of each one of these chapters. Once we had that, then the repair parts follow it in pretty easily. So here, and of course they'll be specific for the type of joint you're working with, but for repair, rutting and extensive cracking of the plug joint, and then maintenance, a section for it. As I said, I think one of the best parts about this is you'll see a whole lot of pictures at the end which go through all the steps that are involved in that replacement. And so just a good example here of the plug joint. Ideally, when we did this, we would have had, say, pictures from one project from start to finish. It didn't always work out that way, so you'll see some mixtures, but picking out the key points of each one of those, or for each one of those types of joints. So you'll see that for the other 4 classes in the draft guideline as well. So the project, as I said, it started in September of 14. It actually finished in September of 16, so it's been a little while. But the final report and the draft guideline are available on the TRB website. All you have to do is go in there and search for that project, 12100. The report, the project was presented last summer to SCOM, coming full circle to the committee that presented the problem statement. And so we presented that last July. And SCOM voted to approve publication of the document and has now sent it along to AASHTO Publications, and it's in their hands right now. And Jeff Milton, who's here, is the one now who's shepherding it through the process. So, cross our fingers, we'll see a flashy, formal AASHTO publication from this project. Just acknowledge the Academy and NCHRP for the project, the panel and the manager, stakeholders, as I suspect some of you took that survey or sent us information, so I really do appreciate all that. The vendors and suppliers were intimately involved in this process as well. They reviewed, a number of them reviewed the final guideline document and provided very substantive comments on it before it was finally wrapped up, so we really appreciate their help as well. So that's it. Let me just finally kind of wrap up by just saying that I'm the academic director for the Northeast Bridge Preservation Partnership and have been for a number of years, and actually we did a very small project for the Northeast on small movement joints before this one. And it was a small project just looking at the Northeast, but it really, put us in a great position to compete for this project, and I think that's one of the reasons why we were successful in getting it. But just, for the other partnership members out there, these small, any little seed project you might have like that, could ultimately lead to bigger things, and it's nice to see that the Northeast kind of helped get this thing rolling. So.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.